All right, let's take a look at some free response questions. And these are calculator allowed, though I'm not always going to use a calculator, especially for something like a question like this, where pretty much all the information is in the picture itself. So let's start with part A. So in part A here, it's asking for us to find all values of x at which f is a relative min. So you might say, oh, this looks like a min here, but that's not necessarily true because our original graph is the derivative. It's not f of x, but it's f prime of x. So then instead what we're looking for is a min happens when the slope changes from negative to positive. So a min, the slope is negative before, and then the slope is positive after. So we're looking for where does this graph change its height from negative to positive, because the slope of f is equal to the height of f prime. That's kind of the key move here. Okay, and where does my height change from negative to positive? That happens here at -1. It doesn't happen anywhere else. There's no other place where we cross through the x-axis from negative to positive to change our value from negative to positive, our height from negative to positive. So we'd say f has a min at x equals -1 because f prime changes from negative to positive. There we go. That's the answer, and we have our answer and our reason. So we have a claim and then a because. All right, now let's look at part B. For part B, it's the same kind of question, except now we're looking for relative max. And a relative max is going to be very similar, except kind of inverted change. It's changing from positive to negative, and that happens here at x equals -5 and nowhere else. So we'd say f has a max or relative max at x equals -5 because f prime changes from positive to negative. All right, let's look at part C. Part C. Where do we see a point of inflection? Okay, well, let's make a quick note about that. F has a point of inflection when f prime changes direction. In other words, when it changes direction from increasing to decreasing, or like positive slope to negative slope, or the other way around, negative slope to positive slope. So where do we see that? So let's do some highlighting here, maybe in green. So a point of inflection, I see that I change slope here, and that would be at -3, and also here at 2, and then once more at 5. So for part C, I would say f has a point of inflection at x equals -3, 2, and 5 because f prime changes from increasing to decreasing, or vice versa. All right, now let's look at part D. What's it asking for D? When f double prime of x is less than 0. So when is it concave down? That would be when f, it's very similar. So if we're looking for f double prime and we're looking at f single prime, then we're looking at the slope. That's another way to say that. So for part D, f double prime is the same as f prime slope. So if we want it to be less than 0, then we want to see where is there a negative slope. Well, that happens for this first interval from -7 to -3, and then again from 2 to 5. So for part D, we would say f double prime of x is less than 0 for -7 less than x less than, is it -3? Yep. -3. And the other one is from 2 to 5. There we go. And, oh, because f prime is decreasing. That's the reason you need to put there. Okay, so when is f both concave up and decreasing? All right, well, we've already kind of looked at some of the concavity, but this is a newer version of the concavity. I'm going to kind of invert the colors here because concave up means I'm not a down slope, but I'm actually an up slope. So that's happening in the opposite of the intervals that we found before. And then decreasing means that, so when is f decreasing? F decreasing means negative slope. That would mean f prime of x has a height less than 0. So where do we have a height less than 0 in these purple zones? It looks like right here. So from -3 to 1 is our zone there. So for part E, we can say that f is both decreasing and concave up. For what's our interval? That's from -3 to 1. Oh, -3 to -1. For -3 to -1. Did it say to justify? Oh, it says justify your answer. Because f double prime, or f prime of x is increasing. That's our concavity. That's our f prime of x is positive slope. So f double prime is concave, or f is concave up because f double prime would be positive. And f prime of x is less than 0. Those are our matching reasons because this means it's a negative height but a positive slope. All right, we're going to finish that one there. I'll leave this here just for a moment if you wanted to pause the video. But that's our first question of this series of FRQs for calculus.